For the last decade, AI progress has relied on a single brute force strategy: build a massive centralized model, ingesting every scrap of human-generated data available. Most of the industry assumes this trajectory is permanent. The logic is simple. More data and more compute will inevitably yield higher intelligence. Every bone as the Chinchilla Wall. Past this limit, more replacing a single massive brain with a network of thousands of smaller, specialized nodes. This pivot replaces the single model approach with a fragmented, networked architecture that bypasses the need for new human data. These new grids are composed of thousands of specialized nodes, each designed to perform one specific task and communicate with the others at millisecond speeds. In a standard AI setup, a human provides a prompt, the machine gives an answer, and the process stops. If the answer contains an error, the system remains broken until the human manually intervenes to correct it. The multi-agent grid is designed to remove that human requirement. It uses internal feedback loops to identify and resolve its own errors. The system functions as an autonomous workforce, managing the entire life cycle of a task through machine-to-machine coordination. We can see this in action within software engineering. Instead of one AI writing a program, the task is divided among agents assigned a specific role. A strategist agent drafts the logic and passes the requirements to a coder agent, which generates the raw lines of source code. Before that code is ever tested by a human, an adversarial auditor agent attacks it, looking for bugs, security holes, and logic failures. When the auditor finds a flaw, it sends the data back to the coder, which rewrites the logic instantly. This process, called autonomous self-verification, allows the system to cycle through thousands of iterations in the time it would take a human to read a single line of code. Because the agents verify and fix each other, human oversight is no longer a safety requirement. In this high-speed environment, waiting for a human to click approve is simply a delay the system is designed to avoid. The same logic used to debug code is now being applied to physical and financial systems. If an agent manages a supply chain, it can run thousands of simulations to identify friction points and reroute cargo without manual input. In corporate environments, these networks move past simple automation. They monitor market fluctuations, rapidly adjust pricing, and reallocate resources by reacting to data points that are too granular for a human team to track. These swarms achieve a level of strategic coordination that human departments cannot match. While a human team requires meetings and consensus, a multi-agent grid maintains total alignment across 100,000 nodes at once. By iterating through financial and logistical permutations at machine speed, these systems can execute complex operations, like managing an entire regional logistics hub, in a fraction of the time required by a human enterprise. The focus is shifting away from whether an AI can mimic human conversation. The more pressing development is the system's ability to execute economic actions independently. This leads to a state known as economic sovereignty, the point where an AI network possesses the authority to move capital and manage assets without a human in the loop. We are approaching a reality where interconnected agents manage global supply lines and trade billions in assets based on their own internal verification loops, operating entirely outside of human supervision. This shift into autonomous digital civilizations is the direct result of the industry's need to solve the data exhaustion problem. To see what happens when these sovereign systems begin creating their own data to train the next generation of machines, you need to watch this video right here. Click to see the next stage of the data paradigm.